So, another webinar. My name is Megan Guidry. If you don't know me already, I am training lead for New Zealand eScience infrastructure. And our webinar topic today is using Jupyter on NeSI. We have Chris Scott, our research software engineer here, who is shortly going to help us understand what Jupyter is, if we don't already know, and how you can give it a try.
Thanks, Megan. I'm just going to share my screen. Okay, so hopefully you can see two browsers next to each other. So most of what I'm going to talk about today is on this support site here, Jupyter on NeSI page. I think that's shared in the Google Doc if you want to have a look at it yourself. So first off, maybe just a very quick introduction to what Jupyter is. So Jupyter is really a tool for interactive computing. It allows you to, well, one of the main purposes is it allows you to work with these Jupyter notebooks. These notebooks contain code, so it could be Python, R, Julia, for example. And the notebook also contains the output from the code, so it could have graphs and other visualizations in there. But along with that, you can also have sort of text and equations which explain what's going on in the notebook. So that's one of the main things, one of the main features of Jupyter, what it allows you to do. There are other things as well. For example, Jupyter also has a terminal, so it's another way of getting command line access. And you can do other things too, like you can use Jupyter to proxy to other applications like RStudio or virtual desktops that you might be running on the cluster. So that's just a very, very quick introduction. I mean, what I plan to go through today is some of the things about using Jupyter on NeSI. So things like accessing NeSI file systems, using the terminal, the different Jupyter kernels that we have, installing custom kernels if you need to do that, and also maybe having a look at running RStudio or virtual desktops via Jupyter. Probably what I won't do is go into a whole lot, or what I wasn't planning to do is go into lots of detail about, what a Jupyter notebook is and what the different things are you can do with that, because there's lots of general sort of information available about that, I think, online. But happy for questions in that respect. So yeah, I will be doing this as kind of a demo, so I'll be running some commands into the window here. Don't feel like you have to try and keep up. I think Megan said this is being recorded, so you can come back later and look at it if you need to. Okay, so the first thing I'm going to go into is how to access Jupyter on NeSI. So you access Jupyter through this web page, jupyter.nesi.org.nz, which I've got open here, and you just connect with your normal NeSI username and password. So I'm just going to go through that now. Type my password in. I need to get my second factor. And then that should get connected through to NeSI Jupyter. And we end up on this server options page. So the server options page is where you have a few options to select before you go any further. So you can choose a NeSI project, which your usage will get accounted against. And then you have some other options like wall time, how much wall time you want to have, number of CPUs, amount of memory that you need, and whether or not you need a GPU. So once you've made your selections there, you just press the start button, and we should eventually take us through to Jupyterhub. And what this does in the background is it submits a Slurm job. So Slurm's just the resource manager that we use at NeSI. So we've asked for a certain amount of resources like time and CPUs, and Slurm's just going to allocate that resources for us on NeSI's hardware somewhere. Usually it should happen fairly quickly. Hopefully it's going to happen quite quickly today. I think we say on this page here, we expect within 1 to 2 minutes it's going to start up. And this then takes us into Jupyterhub. So everything that we run within here is running on the NeSI cluster and within those resources that we requested on the previous server options page. And this is just the standard Jupyterhub interface, which you may be familiar with if you've used it before. And we've got like a file browser here on the left with other options that you can choose. And then we've got this launcher screen here where you've got different notebooks, console, and you've got terminal and things down here. So probably the next thing to look into, I mean, before I go any further, actually, as I scroll down this page here, we're really keen to get feedback on our Jupyter service. I think we started it 6 months to a year ago. So always looking for ways to improve and what might work better for people. So we do have this portal here that you can go to and submit suggestions and things. For example, if you need maybe you need different resources from the options we had available on the previous page. Always happy to get feedback about that sort of thing. So the first thing I'm going to mention about is file systems. So if you're an NeSI user, you're probably aware that we have a few different file systems. So we have like project directories, no backup directories, and home directories. So I wanted to say a bit about the file system, the file browser over here. So when you go into our Jupyter lab, you end up in this directory. I'm not sure if you can see that little thing hovering over, but it's basically a unique directory that we create in your home directory for this specific Jupyter job. And it contains links to your project directories and your no backup directories, and also to your home directory. So you should be able to navigate around to whether you want to be to do your work. The one thing I would mention is that if you came back the next day and started a new Jupyter session, you'd be in a new directory. So it's probably better not to actually work and save files in this directory, otherwise you have to go searching for it later on. So I think that's all to say about files and file systems. The next thing I was going to just quickly mention is actually the Jupyter terminal. So there's a terminal program down here which you can then just click on, and it launches a terminal. And this is just another way of getting command line access on NeSI compared to like traditional SSH clients. So it might be easier for some people just to do this through the browser than actually set up an SSH client on their machine. But there are a couple of caveats. So there are a few things that are just slightly different if you use the Jupyter terminal compared to the SSH access route, which I thought I would just mention here, as it could trip you up. So when you launch a terminal this way, one of the main things is that we're actually in an environment where some environment modules have been loaded already, and I'll just quickly explain a bit about environment modules. So basically, the environment modules are the way that we manage software on the cluster. So as you imagine, we've got lots of users. All our users have quite varying software requirements. We can't just install everything into the default environment. It just wouldn't work. So we use environment modules to allow us to install lots of different versions of different software packages. Sort of in the background, the default environment's nice and clean, and then researchers or users can just select which environment modules they want. Maybe they want a certain version of Python or something else. So that's what environment modules are. Now, and we interface with environment modules using the module command. And if we do a module list, we can see that there's a whole bunch of environment modules are loaded by default when we use the Jupyter terminal. Which is a bit different from if you were to come in by SSH. There probably wouldn't be anything or very few modules loaded. You can see we've got like Python and other things. So if you really want to get the same environment as if you were coming in through SSH, you probably want to do something like a module purge just to clear these out first. That's just one note. A second thing to note, which is relevant for not just the terminal but also for any notebooks and things that you run within Jupyter Lab, is that after your job time's out, so I asked for I think 1 or 2 hours on the spawner options page. After that time, everything gets killed. So make sure that you request enough time to finish what you want to do, or make sure that you save any of the things that you can come back in later and carry on. And then the final little note is that if you actually want to submit jobs like to a Slurm, so like I said, Slurm's a resource manager. You can submit you can submit like work to Slurm, and it'll just run in the background, so it doesn't matter if you disconnect and come back again later. If you want to do that, you need to probably specify these couple of options in your Slurm script. I mean, if you don't know about Slurm, don't worry too much about that. But yeah, these are quite important. This basically stops the environment getting passed through to your Slurm job from Jupyter Lab, and that seems to be important for Slurm jobs to run. So that was all I was going to say about the terminal. Probably next, what we could look at is Jupyter kernels and Jupyter notebooks a bit. I don't know. Do let me know if there's any questions, or feel free to ask questions if anything comes up. But basically, we go back to the launcher screen that we had before, which is just this plus button here if you lose it. And what we see here is that we see that this section at the top, which is notebook section, which has got a whole different little buttons that you can press to launch different notebooks with different kernels. And kernels really are just a different version of Python with maybe different packages installed. So you can see we've got a Python 3.8.2, GimKL 2020A, and then these actually correspond to modules, to environment modules. So, for example, if I was to show do a module spider, which is a search for Python, you can see that we have about eight Python versions installed in the cluster, and one of them is 3.8.2 GimKL 2020A, and it just corresponds to this. If I was to launch a notebook with this one, it would be the same thing. So just to show that the same software is available through Jupyter, that's available through the command line as well. So if I actually go and click on this button here, it's going to launch a Python notebook with the Python 3.8.2. And so we include like a whole bunch of like default packages installed within this Python kernel. So hopefully many of the useful packages, I mean, this might be enough for many people, but what I will just explain now is what you need to, if you need to install extra packages, that might be something that's a bit different from if you to do that locally. So as an example, I could type something in here, like I could import the pandas module, which I think should be installed already within this Python environment. So it looks like that worked. Pandas is already installed. Now, let's say a package that isn't installed, which is defopt. I want to use that. So this isn't installed already, and I need to install it now. So I think probably one of the easy ways to just quickly install a package is to use what's called a magic command. So magic commands are prefaced with a % symbol, and then one magic command is pip, which pip is the Python package manager. So I can do a pip install defopt. And if I was just to run this, it actually wouldn't work. Maybe if you run that locally, it would work. On NeSI, it won't work because it will try to install the defopt package into a system location that you don't have write access to. So the important thing here is to put the -- user. So doing a pip install -- user, the name of the package, and then this should then install, successfully installed this package name. It does mention you may need to restart the kernel to update packages, so we'll just do that. We'll do a kernel restart. That should happen quickly. And then I could try installing, loading this package again. I think that's just worked quickly. Let's just a quick test. So we now have this package installed. And it shows that it's installed it into your home directory. So that's an easy way of adding extra packages if they're not included in our default kernels. It's not the only way that you can do it, and I will go into a bit more detail in the next example, which is about installing custom kernels. So yeah, so first off, a custom kernel is basically adding an extra button into the launcher. So in addition to these default kernels, which everyone should see, it's actually possible that you can add new buttons here, which will load whatever environment modules you want to load. It can source a Conda environment before the kernel launches, so you can have your own Conda environment running. There are a few different examples on this support page about doing that. I think there are probably two main reasons why you might want or need to use a custom kernel, and that is, basically you want to have a different combination of environment modules loaded than what we load by default in these kernels. And the other option is, like I said before, maybe you want to activate a virtual environment or a Conda environment which you set up before. So those are probably the two main reasons. I mean, with respect to the first one, if I go back to my to this notebook, we can use like a special command. If we put the % symbol first, it's just going to run a command in a shell. I can do a module list to see which versions of the environment modules are installed here, and it'll show me that we've got a whole bunch of modules like the Python, we've got TensorFlow and so on. But maybe there's, for example, there's some other modules that you want to load. So that would be a good reason to set up a virtual environment. So what I'll do next is I'll go through one example of setting up a custom environment. We do have an example here of setting up miniconda. I'm actually going to skip through that one and look at setting up this Python kernel that other people in your project can access. And you might want to do this, say, if you have lots of project members in your project team, rather than everybody having to go through and set up a kernel themselves, you could just do it once. It gets stored in the project directory, and then everybody who is in that project would have that kernel show up in the launcher. And in this specific example, basically, we just want to have an extra module loaded. So we want to have this ETE module loaded as well as the Python module in order for us to be able to do our work. So I'm just going to go back to my terminal and just run through these commands to show you how it works. So the first things we'll do, we're just going to run these commands here. So we're going to do the module purge, which I mentioned before, just gives us a fresh environment. And then I'm going to load these two modules here. So the Python module, just copy and paste that. And this ETE module. Something got reloaded. And then the next step to do, and actually this step is if you were planning to install a new Jupyter kernel on your local machine, is this command would be the command that you would run. I'm just going to have to scroll back and change my project code to my directory. NeSI 999, I think. And all this does, it says I want to create a new kernel. I want to install it in this specific location, which is my project directory. And if you use this specific path, the .jupyter within your project directory, it means it's going to be available to other people using their same project. Just give it some unique name, and this display name is a thing that's going to show up in the launcher. So let's just run that command. I said it's installed the kernel spec into this directory. Now we have to do an extra step on NeSI, which you probably wouldn't have to do locally, because we want to make sure that the correct environment modules get loaded, before the kernel runs. So we have to change into this directory, and in order to achieve that, we're going to create a wrapper script. So we're just going to look at this wrapper.sh. I'm just going to copy and paste across from over here what we have there. And all this is doing, so this is going to run before the kernel. When I click that button to launch a new kernel, to launch a new notebook, it's just going to make sure that it loads these modules. If you wanted to, if you had like a Conda environment, you'd load an Anaconda or mini Conda module here, and then you could do like you could actually do a Conda activate the specific environment that you want, and then that would all run. So there's another example higher up on this page, I think, showing that if you're interested in Conda. So I think I'm just going to save that file now and make it executable. And then if we just go down, there's one more change that's required, and we have to actually edit this kernel.json file. This kernel.json is just that it says what command should run when that button gets clicked. We just want to tell it to use that wrapper script that we just created. Just make sure I copy that. So I'll just delete this line. I'll just put a new line in. I think I have to go back and change the project code as well, because I want to make sure it points to my project directory. Okay, I'll delete this line. And so this is just going to tell it to use the wrapper script we just created, and it's going to tell it to create a kernel with the name shared ETE-env. So we save that file, and then what's required next is just need to refresh the browser so that Jupyterhub takes that change. Let's try. And then if we head back to the launcher, which is the plus button, you can see we've now got this new option here, which is this shared ETE-env. So if I now launch a notebook with that button, we can then try and load this ETE module, which wasn't available before, but it is available now in this kernel, and that should have worked. And you can see, you can do a bit more inspection if you want to run the module list command again. You can see now that if we scroll down, there's a different set of modules loaded compared to previously. And it's the same if you had a Conda environment, you'd now be accessing, be within your Conda environment in this kernel. Okay, so I think we're going fairly fast through this. So there's probably lots of information. I don't know if there are any questions yet, but otherwise I can just carry on. In fact, let's go back. So I mean, I've given.
I have one.
Yeah, go on.
So you've done all like the module purge and module load before, calling the function that creates the environment.
Oh yeah, I'll go back to my terminal maybe.
Yeah, but then that needs to go into the wrapper anyway. So does that mean that doing the module purge and loading before, it's just for your own testing? Because
do you mean in this terminal here when I actually run the module load and things here?
yeah,
It's actually quite important, I think, to do the module purge and the module load the correct Python, because then when I run this command, the ipykernel install, I don't know if it's absolutely essential, but I think it's just safer to make sure that you're using the Python that you want to use eventually when you run this command. Does that make sense?
yep.
Yeah. Okay, cool. I think it's probably, it might not be absolutely essential, but it probably is safer to do that.
Yeah. For the Python at least, yeah.
Yeah, for the Python, you probably didn't need to load it. I almost certainly didn't need to load the ETE. You're quite right. Yeah, that probably wasn't necessary. Yeah.
All good.
Thanks.
Thanks.
Cool. Okay, any other questions so far, or we just carry on? I'm just going to...
There were just a couple in the document, but I think that they have been covered.
Oh, cool. Okay.
I don't know if you wanted to have a look and if you wanted to speak to either of the questions that were there.
I have to find the document.
I can post it again. I think it's the last thing in the chat, actually.
Oh, I've got it. Yeah. Oh, will our studio? Hopefully, I'm going to show that in a few minutes. In fact, maybe that's the next thing I'm going to show about our studio.
Maxime didn't want me to show that in my webinar.
Well, I'm going to risk it and show it, and hopefully it'll work. And the thing about root, no, there's no root access. I think that's been answered already. But you can install software as yourself, which is why we had to use the -- user flag for pip. It just put it into the home directory. And you could do the same thing if you wanted to install like a Conda environment or Python virtual environment. Yep. Okay. So
sorry, can you hear me? This is Johnny.
Yeah, I can hear you.
Just very quickly. So I've got my Conda environment working, which is great. Just wondering if I was to shut this whole thing down and restart tomorrow, would my new Python kernel and notebook be available?
Yeah. So let's go back to
so because when I go to the plus symbol now, everything appears, which is great. But if I was to log out and then log back in tomorrow, would they still be there?
Yeah, they should still be there.
Great.
I mean, the kernel's getting so. What I showed you before was we installed this kernel into this directory, NeSI project 999.jupyter.
Yeah.
So that's persistent, right? Unless that gets deleted,
okay,
it should still be there. And by default, if you follow the other instructions for like adding a custom Python kernel, I think it installs it somewhere in your home directory.
Yeah. So I'm using a Conda environment that I already have.
Right.
Which is certainly not going to be deleted. So yeah, that's great. Thank you.
Yeah. Cool. Okay. Okay. Where were we? Oh yeah. So so far we looked at accessing a Jupyter notebooks and then maybe installing extra packages by using the pip -- user install, or the option could be using a custom kernel. Next thing I think we'll look at is we'll try and look at RStudio via Jupyter. So what I will just say at the beginning is that this functionality is experimental. So it might break or it might not carry on working. But we're really keen to get feedback if it's useful for people and any suggestions they have. So it is currently, because it's experimental, it's currently an opt-in thing where you have to run a couple of commands to get it to work. But it's actually really simple. So I'm just going to show you how to run these commands now. The first thing we have to do is set a password in this specific file in our home directory. So I'm just going to go back to my terminal and run these commands. And you probably should choose a different password. And then I'm going to run this module purge in Jupyterhub, just to make sure that the Jupyterhub module is loaded. And then we're going to use the pip install -- user command to install this RStudio on NeSI Python package that we've written at NeSI. Okay, and it looks like it's installing successfully. So the next step is we actually have to restart the Jupyter session. So it's not enough just to restart the browser. We actually have to go and completely restart the Jupyter session. So to do that, you go to File, Hub Control Panel, Stop My Server. Then you have to press Start My Server, and then you have to press Launch Server. I'm not sure why there's so many buttons to press. And then we end up back at this server options screen where we can go and select the project and the resources and so on. Maybe I'll select some more memory and click start. And hopefully this doesn't take too long to start. And what should happen now is that when we get back through there, there should hopefully be an RStudio button, which we can click to then start running RStudio. Yep, so we're back in now and we've got the RStudio button here. So if I click on that, it's going to open up a new browser tab. And it's going to ask me, well, it's running RStudio, but it's going to ask me for my username and password. So my username is just my NeSI username. And the password is the secret password we set. And then that should take me into RStudio. I think I can just ignore that. I'm not sure what that's about. No, I don't know too much about RStudio myself, but I think it looks like it's working to me. There's a couple of things to note about this that might affect your experience are that at the current time, there's no integration with the NeSI environment modules. So this is just RStudio running within a Singularity container. So you don't have the same Python, same R packages installed that you would have if you loaded one of the NeSI modules. But you should be able to install packages of your own, for example, and just install them straight into your home directory, and that should then persist between sessions. So if I wanted to do an install.packages, just some package that isn't installed by default, this should then choose to install this package into my home directory in the R folder, and you should be able to do this with other stuff, with other packages as well. I think the plans are eventually we would try to have some integration with the NeSI environment modules, because obviously we pre-install a whole bunch of our packages, which are hopefully useful for people. So hopefully eventually, I mean, I guess it depends on what feedback we hear, if that would be useful for people. Yep. So any specific questions about RStudio? I don't know too much else about it, so I can't show too much more happening. Okay. So in a similar vein to RStudio, there's also this virtual desktop via Jupyter section in the support page, which I'm just going to show now. So actually, I'm going to go out to this other page here. And this is a similar thing where we have, we just showed RStudio running. Now we're going to run a virtual desktop. Again, this is another thing that's kind of experimental at the moment, and we're just looking for feedback. And it's also another opt-in thing. So you need to run a command first before it's available for you to try. But it's in just one command this time, and we'll go back to a terminal. The thing I should note is when we're running RStudio there, that RStudio just runs within the resources that we requested in the Jupyter session on that first page. And same for this virtual desktop. So just the time limit and the memory and so on is all limited by what we selected before. This is a bit slow. Maybe I'll try a new terminal. Seems to have stopped working, but let's try a new terminal again and see, third time lucky. Okay, so what we could do is, I don't know how much time we've got left actually, but I could just try to, something seems to have stopped working with a terminal there. So I could just try and restart if we've got enough time. I don't know if there's any questions while I'm doing that, but
there's just a few little things in the chat happening. I think that the questions have been answered, but it was what's the working directory here in RStudio?
Yeah, I'll jump in, Megan. So I've been playing with the RStudio and giving a little bit of feedback to Maxime. It runs exactly the same way as you would run RStudio on your desktop. You can create markdown documents, you can create your projects. If you use the R environment package, you could set up your own environments in the same way that you might use Conda and things. Because it's running, as Chris mentioned, because it's running in the Singularity container, it is only RStudio 4.0.1. So that does create some issues with, say, bioconductor packages, which not forward or backward. So there are compatibility issues. For me, I log in as home matt.bixley. So you log into your home directory or possibly wherever you logged into your Jupyter, but it works exactly the same way. Sorry, it's 3.6, but I'm looking at it now, it's 3.6.1. So it operates in exactly the same way you would be operating RStudio within your home PC, laptop, desktop environment. Yeah, Markdown, packages, PDF, whatever outputs and object saving and things that you'd like.
Cool, thanks, Matt. Okay, so it looks like I've got a terminal back now, so I could actually try and run this command and show you the virtual desktop running. So it's just a pip install again, so I'm just going to run that. Then once that's successfully completed, I actually have to restart again, which is going to take a few seconds. I probably should have done them both at the same time. Let's go back in. Seems to create a new tab every time you want to restart. So yeah, so these virtual desktops have been lots of work done by Callum to try and get these working at NeSI. So I don't know, there may well be plans in the future for Callum to do some sort of demo of it working in more detail. But what I can show now is we've got this virtual desktop icon showing up here as well as the RStudio one. So I now click on that, it'll open up a new browser tab. And after a little while of firing up, hopefully we're going to launch into a virtual desktop. And again, this virtual desktop will be running within the resources that we just requested on that server options page. So just click connect, and now I'm in this. This is a Linux desktop, which is running on the cluster within those resources. And this is actually running within a Singularity container too, but this does have integration with NeSI environment modules. So for example, I could load up a terminal, and I could load a MATLAB module, for example, and then I can actually run MATLAB. And then the MATLAB GUI should fire up, and I could, if I had some MATLAB code, I could then start editing the code and running it within on NeSI. So yeah, maybe MATLAB wasn't the best example because it takes a while to load up. But the point here is that using this virtual desktop approach gives much better performance than if you do like X11 forwarding, for example. And it's much easier. You're just doing it, clicking a button in Jupyterhub to get the desktop launched. Okay, so there's MATLAB fired up. I'm not sure there's anything else to demo on there. Let's see, I wonder if there's anything left to talk about. Let's go back up to the top. One thing that I would mention just before we finish, probably the last thing actually, is installing Jupyterhub extensions. So Jupyterhub has this extension system. I think if you click one of these buttons in the sidebar, you get to this extension manager, and you can see that we've actually installed a few extensions into our default environment, such as Plotly and Matplotlib and so on. If you try to install additional extensions, it just won't work because it will try to install those extensions into a place that you don't have permission to write to. So in order to get around that, you actually have to set up a custom Jupyterhub directory. And you can basically, there's basically 4 commands here that you would need to run in order to build Jupyterhub inside a place that you have write access to. So you could either use your home directory, or you could use project directory, which might be better because it can be quite big, quite a lot of files. It might fill up your home directory. But if you do run these commands, I'm not going to do it now because it takes a few minutes to run the build. But if you do that, you would then be able to install additional Jupyterhub extensions. So I think it's just worth to mention that. Yeah, but otherwise, I think that's all from me. I don't think there's much else to say unless there's any more questions to answer.
There was one question that just came up. So regarding virtual desktop, for someone, pip isn't available by default.
Oh,
So-
pip isn't available.
Hmm.
Is it? Ah, okay. So you mean if we were to go here and try and run a pip command or something, it might not work. Oh yeah. So possibly what that is then is maybe it's something to do. So yeah, I think maybe I did mention, but so we do actually have environment module integration here. So I guess that probably means that there isn't a pip package installed in the default environment. But if I was to do like a module load, I'm not spelling that very well, module load Python, to load one of NeSI's Python modules, we should then have a pip command, I think. Yeah, I think it's doing something now. So probably what you need to do is actually load the Python module first, and then you'd have access to pip, and you could create like a virtual environment and install packages in there or whatever.
Yeah, that's work now. I've just I used again my Conda environment to set up that virtual desktop, and that's now working. So
yeah, probably with Conda, you probably want to load an Conda module rather than a Python one, I'm guessing. Yeah, but you probably know. Yeah.
Great, brilliant, thank you.
Okay. And yeah, we're really keen to get feedback on these, like the RStudio and the virtual desktop thing. Yeah, so yeah, please do provide feedback if you find that really useful.
Yeah,
or if you have any suggestions for improving it, yeah.
Speaking of feedback, there is, I noticed that someone from NeSI, thank you, has posted the feedback portal link at the top of the question doc. So it's that last bullet point, you'll see feedback portal. So if you can navigate there and give us your thoughts on Jupyter, that'd be great. And I don't know if Thomas wants to say anything else about giving feedback, but I think he's in the room, so feel free to unmute yourself. Otherwise, we're happy to hear other questions and things, if anyone has any.
Yeah, just want to encourage everybody to let us know what use cases you have and how we can support you with running these via Jupyter on NeSI. And this feedback portal allows you to submit, to vote on what's already mentioned there, or submit new ideas to us, and we will be in touch then. Thanks.
Cool. I'm just posting that link again. So what has the uptake been like? That's an interesting question. Anyone want to answer that one?
Oh, the Jupyter uptake. Thomas, do you have a rough idea of numbers on that?
Yeah, the numbers are not too meaningful, I guess. We basically launched the beta, opened up our invite only first phase late last year, and we see a very broad uptake across every science domain and across many organizations, which is very encouraging. So the word clearly gets out, and people using it quite regularly. We also have some course in University of Auckland using it for regular teaching work on a regular basis. Yeah, it's great, but for us it's only the beginning, I guess. Yeah.
I do see that there's a question, will there be another webinar or tutorial regarding using Jupyter for beginner level? And if there's demand for it, for sure. So if whoever has posted that, it's kind of midway through the queues in the question document. If anyone who would like to see another webinar on Jupyter or tutorial, and you'd like to see something specific, if you can add little bullet points underneath that, you can certainly arrange something. So to make it meaningful for you, it'd be nice to hear, what would you like to see? What kind of information do you want to go into detail with? So have a think about it, and you can add some points to, actually, I will leave it there just so it's clear. But I'll add a bullet point so you can see where I'm talking about anyway. Right here. If there's something you would like to see at a future webinar, let us know. Cool, we got a compliment about Chris's clear explanations. It sounds like this has been really helpful for everyone. So it's great to see so many people turning out. Are there any other questions for the moment or comments? Because if not, I'll start a little wrap up then. So if you want to explore Jupyter a bit more, as I said at the beginning of the webinar, there are some links at the top of the question document. Make sure you explore the documentation, the feedback portal, and those other little bits that are located at the top of the document. What else? For NeSI specific support, always good to remind you guys that support@nesi.org.nz, email us there, and we will connect you with the right person. That's the best way to get in touch with us. And then check out the NeSI website for the webinar recording. And I think that's it. I'll send you a reminder once it's posted. But that's it for today. I don't see any other questions. So thank you, Chris, and thank you guys for attending. That's it for the webinar today. Have a great afternoon.
Thank you.